Ni hao. Thank you, everyone, for turning up at nearly 5 o'clock after a long day of technical sessions. We're very grateful to have you here to talk about how Flutter renders widgets. My name is Matt Sullivan.
My name is Andrew Gibbon.
And we're going to spend the next half an hour talking about how Flutter works under the hood. What we talk about today isn't really necessary for your day-to-day job by writing Flutter, but it will give you a solid understanding and help you to build performant Flutter apps.
And so just to remind you, in case you missed it from the keynote this morning, Flutter is Google's UI toolkit for building beautiful applications on the web, mobile, and desktop. Now, as you can see, you can do very interesting things with Flutter. And so we are going to do something very simple. We have an app that has some text in the middle of the screen. That's all we have.
This is like the simplest Flutter app ever.
This is the very simplest app ever.
2 widgets.
We have 2 widgets. That's it. And so when you first learn Flutter, one of the things you learn is that everything is a widget. And what we do under the hood is we build this widget tree. And in this case, we have a center, and we have a text. But let's make it a little bit more interesting, just barely more interesting, and make the background white. We do that by adding a container at the top.
3 widgets.
We now have 3 widgets. And so our widget tree looks like this. We have a container at the top, a center, and a rich text. So I think, Matt, it's undeniably true that everything in Flutter is a widget.
It's undeniably true.
It's undeniably true.
It's uncategorizable. I just made that word up.
You just made up that word. That's great.
Well, in reality, that's not necessarily the case. Because if you dive into our documentation, you will see statements like this, where it says a widget is an immutable description of part of a user interface. So looking into the docs, you think about this and you go, well, you know, immutability and UIs don't go hand in hand because UIs are not immutable. Different parts of your UI mutate and change. Your UI is constantly in flux, new widgets come in and go, pieces are swapped in and out. But if widgets are immutable, how does Flutter manage the state of your UI? How does it represent change?
That's a great question, Matt.
It is a great question, isn't it? I'm going to answer it.
Thank you.
So in reality, what Flutter has is Flutter has 3 concepts for this. It doesn't have one tree of widget. It actually has 3. It has the tree of widgets, the widget tree. It has a tree of elements. And finally, it has a 3rd tree, which is a tree of render objects. And these 3 different concepts we combine together to make UIs rendering, or the rendering of a UI as performant as we possibly can. So these are new concepts, maybe for some of you. So let's look at the Flutter documentation again and see what it has to say about these 3 things. So we've already seen that a widget is immutable. And so that kind of makes sense, because you are working with a declarative framework. You declare what your UI is going to look like. And so you configure it, and you configure it with widgets. And so a widget describes the configuration of an element. So what does that mean for an element? Well, in fact, what an element is, it's an instantiation of those widgets. It's the mutable piece of the tree, for want of a better word. It's the thing that manages updating and changing of the UI. It controls everything. You can think of it as managing the life cycle of widgets. And thirdly, we have a render object, which is an object in the render tree. And basically what that means is you have a tree of render objects, and that is what is going to lay out and paint your UI. When Flutter draws your UI, it does not look at a tree of widget. It looks at a tree of render objects, which controls all of these things. So let's look at this from a slightly different perspective. We have configure, lifecycle, and paint. And so how does this map to UIs? Well, on the configuration side of things, configure, lifecycle, and paint. Maybe I should click faster. So when you configure your UI, basically this is you writing widgets. You are assigning properties and values to the components, and you're doing it through an API. And that's what ends up as your widget tree. Then you have the lifecycle. And this is what is going to manage the whole lifecycle of UI. It's going to work out what components exist in your UI hierarchy, and it's going to manage the relationship between these elements and handle their mutation and morphing. And then finally, you kind of have to paint your UI. You actually have to draw these things on screen. And that's where render objects come in. Each component knows how to paint itself. But importantly, it also provides constraints for its children. So for example, when you saw a center widget and you have some text, what's happening on the rendering side is that that center is constraining where that text can paint. So these three concepts, configure, lifecycle, and paint, they map really nicely onto the separation of concerns that Flutter has between widgets, elements, and render objects. And so we have our widget tree, which does, this is where you define, this is where the configuration happens. We have our element, which is going to handle our lifecycle. And we have the render object, which is going to lay out and is going to paint. And so you combine all these things together into these three trees, which have these three different separations of concerns. So there's a whole bunch of theory here, and you might be asking yourself, well, this is great, but this sounds more complicated than I need to render a UI. Why are you creating three things when one might be perfectly acceptable? So let's start to jump in at a slightly lower level and see an example of this. And we're going to play with
Yes. So
padding.
Now that Matt has read us the documentation, thank you, Matt, we're going to look at some real code and some real examples here. So take, for example, padding. It's a very simple widget. All it does is add some space around things. So here's the code for it. We have some padding, and it has some text within it, and it adds some space. Very simple. Let's remind ourselves of the responsibilities of the three trees. Widgets configure, elements manage, and render objects paint. In the case of padding, our widget has two responsibilities. It needs to know how much padding, and it needs to know what is its child. The element here really doesn't do anything much other than manage the widget and manage the render object. And so speaking of the render object, it also doesn't have to do much. All it has to do is it's responsible for layout and size. And in the case of padding, it just needs to remember enough size for the child plus its padding. And that's it. That's all our three trees do. And so by building your UI declaratively like this, you can actually get very performant apps because the Flutter framework doesn't have to destroy very much. It can reuse a lot of different components. And so that still felt a little bit like theory. We still haven't really seen code, right? Like, I showed some code, but it hasn't really.
No. So again, let's drop down another level, and let's actually look at the source code from the Flutter framework for when it creates a Flutter app. And what, again, is the most simplest app that we can come up with?
That same app that we showed right up at the beginning, nothing but text.
And no center object. There's
and
only
no
one widget.
center. There's just a single widget. And so we have our rich text. When Flutter starts the app, it calls the run app function. It takes that widget that you give the run app, and it puts it at the root of the tree. Now we have our widget tree. It has a single widget at the root, nothing more. The next thing the Flutter framework does is ask the widget to create the render object. Creates the render object element.
Yes.
Yes, the
Element first, render object later.
That's right. We'll
Okay,
get to the
good,
render object
good.
later.
OK.
So Flutter asks the widget to create the element. And this is called the leaf render object element in this case, and that's where I got confused.
And it's a leaf element because it's at the leaf of the tree. Again, our trees are only one level deep with one widget.
Yes. The next thing Flutter does is ask the element to create the render object. When it does that, the widget then passes all of the configuration required to paint whatever that widget is. And so in this case, it's text, and so we have a number of text-related properties. And now we have our widget trees. We have our rich text widget, our leaf render object element, which does not need any children, and our render paragraph, which actually does the painting. And so while I was talking about that, it felt kind of weird to me because sometimes text changes. You want to change the label of a button, or you want to change some other aspect of it. And so, Matt, what happens when something changes in our widget?
So again, you're probably still asking yourself, why do we have 3 trees for this? We seem to be doing a lot of work to get one thing on the screen. And so the magic really starts to happen is when things change. And what we're going to do is we're going to effect a change in a Flutter app in the simplest way possible, which means we're going to call run app twice in the same app.
Run app twice?
Yes, run app twice. You would never call run app twice, at least not, I couldn't think of a good reason for doing it, inside a Flutter app. But what this does is by calling run app, it's going to take that first widget and it's going to replace it with a new widget, and we're going to examine what happens to our super simple tree in this use case. So we have our app, and it's going to go from this to this, which is basically run app creating the first rich text widget, and then run app creating a new rich text widget with different text. And as you can see when we run this, the second piece of text is shown. How does that get rendered on the screen? So here is our 3 trees: widget, element, and render object. And the first thing that happens is run app is called, and it pops our new widget onto the root. And at this point, Flutter's asking itself, what am I going to do in this case? I'm replacing one widget with another widget. I've already done all this work to create these elements and render objects. I'm going to need to work out what I can reuse, if anything. And what it's going to do is it's going to call in the widget the canUpdate method. And this is very, very simple. All it's saying is, when I'm comparing 2 widgets, are the runtime types of both widgets the same? In this case, they're both rich text, so yes. And do the keys of these widgets match? And we're not using keys at the moment, so that doesn't matter. So we have 2 widgets, both of the same run type, and Flutter goes, aha! I can get rid of my old widget, and I can now pop it back into this hierarchy of trees. So what happens next is the element goes, well, hey, you've just changed the widget that I point to, so the configuration may be different, so I kind of need to do something. And so what happens at this point is element will call update render object, which looks very similar to create render object, except that what it's doing is it's taking the existing render object and it's updating the values inside it. So our render paragraph is updated, the text is updated, and the next time Flutter paints the UI using our render object tree, it's now going to paint the new values. But notice what's happened here is we've swapped in an immutable, one immutable widget for another immutable widget, and we haven't created or destroyed anything else. We've done a simple update. So that seems like we've gotten some performance gains from that, which is nice. But having a widget tree of level 1 or depth 1 seems like kind of a super simple example. So what happens when we have multiple widgets in the tree?
So if we remember actually to our first app, we had 2 widgets. We had our text centered in the middle of the app. And so now we have 2 widgets. We have center and text. And so our widget tree looks like this. Flutter's going to go through each of these widgets in turn. And it's going to start at the center. And it's going to ask the center widget, what is your element? In this case, the element is a single child render object element. It's a bit of a mouthful, but it means it has a single child. Pretty simple. It then asks that element, or the widget rather, to create the render object. In this case, the render positioned box only has to know where on the screen to put the child. And that's it. That's all it does for center, and then it drops down to rich text. And again, we have our leaf render object element. And Flutter knows in this case that the last element it created needs a single child. And so it gives a reference to the leaf render object element, again a mouthful, but that's OK, up to the single child element. And then, as you'd expect, it creates the render paragraph render object. So once again, I feel myself wanting something to change. And so Matt, what happens with multiple widgets when something changes?
Well, so far you've learned that we have difficulty naming element classes.
Yes.
When we have leaf, single element, object, tiled, element. But what we're going to do now is we're going to do exactly the same trick as we did before. We are going to take our app, and we are going to take our widget tree, and we're going to call run app twice. So in both cases, we have center, and we have some rich text under it. Only when we call run app a second time, we're going to change the properties of rich text. So again, we have two widgets with different properties at the leaf nodes. So this is going to start to seem familiar to you. We now instantiate the new widget tree. So we have center and we have rich text. Remember, these two center widgets that you see are different. Widgets are immutable, and we created one, and now we've created a second. And so what happens is Flutter goes, OK, two center widgets. They have the same runtime. I can probably reuse that. These two rich texts also have the same runtime, so maybe I could reuse other parts of the tree, and that's what it does. So it blows away our old widgets, and it pops our new widget tree, and it links in our single child element to center. At this point, it will call update. But remember, because center doesn't really have any properties other than its child, what happens here is that render position box doesn't change, our single child element doesn't change. So we've popped in a new one, but at this point, our render tree and our element tree have stayed the same. We now wire in rich text. We're going to call update render object and that, and what will happen is our render paragraph will be updated. So looking at this, again, it's a simple example, but you can start to see that the reason we have these three concepts is because it helps us optimize the amount of work we need to do to go from one UI state to another. We don't throw everything away. We try to reuse as much as we can. And so this will go for when you have multiple children. We will do the same thing. You might see an example of that in a second. And when you have deep trees or broad trees and you're changing different pieces of it, we will run through the same process, and we will try to get from this state of your render tree to the next state as quickly as we can so we can maintain those frames per second, and we have to do the least amount of work to get there. So again, this has been a little bit of theory on that. So to round it all off, what we can do is we can look at a demo. And so, Fitz, what are we going to demo?
Yes, so I didn't walk away from Matt for no reason. I actually came over here to show you some actual code. I know things have been very in the slides. We haven't seen very much real things happening. So I want to look at that right now. And so here is another simple app. It looks very similar to the simple app that we've been working with. We have some text, an image. At the very bottom, we have a button. When I click on that button, the text and the image change from hello Flutter to hello Dart and back again, however many times I want to do that. The code for this app is also very simple. At the top with our run app, we have a widgets app. And the widget app has a single stateful element. Now, this stateful element also doesn't do much. It has a button, and it has two trees that it switches between when we click the button. And you can see here that these two trees are almost identical. We have our rich text, and we have an image, and we have some space in between them just to make things look kind of nice. OK. Now, what we remember from the talk is that when we replace some widgets with new widgets of the same type, we expect the render objects to stay the same. Now, the way we can do that here is use the Dart developer tools. So I'm going to open those up. And the Dart developer tools are a set of browser-based tools for debugging and analyzing Flutter and Dart apps. And so you can see here on the left, we have our widget tree. And this is almost exactly what we'd expect. At the root, we have our widgets app. That's what we called run app with, was the widgets app. And then all the way down onto our rich text, our sized box, which we use for spacing, and an image. OK. Matt, can you do us a favor?
Sure.
I would like you to take some notes.
You want me to take notes now? OK.
I would like you to take some notes. And
I'm going to use some very, very sophisticated technology.
You're going to use an app that you wrote just for this?
I'm going to use this.
Oh, some paper. OK. I'm not familiar with that.
And I remember it. I'm going to use this.
Oh, great.
So what notes would you like me to take?
I would like you to note the instance IDs for our render objects.
You want me the instance IDs for the render objects? OK.
Yes. So you'll see down here, for our render objects, there's this series of numbers and letters. And that indicates the exact instantiation of that object in the render tree. OK. So each one of our widgets has a render object, as we saw earlier. So we have the one for the rich text, the one for the sized box, and all the way at the bottom, we have the one for our image. OK. And so you can see here, you can also look at all the properties for the widgets, too. So you see here in our rich text, we have hello Flutter. And that's what we would expect, because that's what's showing in the app. So I'm going to click our Switch Tree button. And now we have hello Dart with the new image. And I will refresh the tree, go back and look at that. And we can confirm that everything's changed, because our text property in the rich text now says hello Dart. OK, and let's look at the render object instance IDs again. Matt, how does that compare to our notes?
Which is identical.
What's that?
It's the same.
Oh, great. Excellent.
You sound surprised.
So our render object instance IDs are the same for the rich text, the sized box, and all the way at the bottom again, the image. Right?
Yep, all the same.
Perfect. OK. But seeing that nothing changed isn't very exciting. I'm going to go to the code now. And we used sized box for some spacing in between our text and the image, and again, just to make things look nice. But we can also use padding. So I'm going to change the code to have padding. I'm going to save that and click on Switch Tree. Because of Flutter's hot reload, I don't have to relaunch the app at all. I can just have it running here. And when I go back to the Dart developer tools and I click refresh, in fact, I can see that it's the new app because our widget tree has changed to padding. Great. OK, let's look at, I'm going to click refresh again and look at our render objects again. Matt, is that the same instance ID for rich text?
Yes.
Excellent. Is this the same? That's not even the same render object for padding, is it?
No, that's a different render object. And that's not surprising, because you have taken a size box and you have taken a padding widget, and they're not the same runtime type. So you don't even know what Flutter didn't even know what type of render object it was going to create. So that's why it's had to destroy it and rebuild the element and the render object for that widget.
Right. Exactly. So the padding render object has changed, but we expect that to happen because it's a completely different widget. And our image is still the same render object. The interesting thing about the image render object is that even though the image itself is changing, and this feels like something that might be expensive because it's a new image, but in fact it's using the exact same render object, and Flutter is just telling it to render a different image file. OK, so now I'm going to switch tree again and refresh our widget tree. And so we've seen now that the sized box has come back. Our render object for the rich text is still the same one. But let's look at the sized box one. Matt, how does this compare to the previous ID we had for sized box?
That's a completely different render object.
It's a completely different one. Yeah. And so what we've seen here is that Flutter took our padding, and then when it was trying to replace it with a sized box, it determined it didn't need padding at all anymore. It didn't need padding. It didn't need whatever its element is. It doesn't need whatever its render object is. And it just threw it all away. And then it created the ones for sized box. But that's OK. It's OK that it did that, because basically nothing else in the app had to change. All of the other render objects, all of the other elements stayed exactly the same. So let's switch back to the slides and wrap it up.
And so we showed some fairly simple examples. And in reality, when you build a Flutter app, you will have hundreds and hundreds of widgets in several layers of depth across a broad spectrum. And rebuilding that entire tree is super, super expensive, which is why Flutter adopts this method of using these three concepts to minimize the amount of processing it needs to do to make these changes. So let's wrap ourselves up. No, let's wrap this up and remind ourselves of the responsibilities of the three trees. Widgets are there to configure your UI. That is what you were writing. You were declaratively defining what your UI is going to look like. Elements are there to make sure everything plays well together, and that your widgets, when they change, are changed out, things will be updated accordingly. And render objects exist to paint things to the screen. And using these three trees is why we are very happy with the performance that we get out of Flutter apps. Thank you very much.